Here's a little bit more about calculating differentials, a little bit more about differentials. So each derivative we've learned to take can be written in differential form. Our same rules apply, and it's really no big deal. Here's our rules right here, formulas, and it'll make sense when I do a couple of these problems down here. Okay, so find the following differentials. Well, when we took the derivatives, we said dy over dx equaled 2x. Okay, so our differential is just going to be dy equal to 2x dx. That's it. This means differential there. That's all we do. It's pretty simple. So again, our derivative for 2 sine x would be dy dx equal to derivative of sine is cosine, so 2 cosine x. All right, so our differential would be dy equal to 2 cosine x dx. All right, for letter C here, x times cosine x, we have to do the product rule. So our derivative is dy dx equal to the derivative of the first one times the second one, just cosine x, plus, leave the first one, take times the derivative of the second one, so negative sine x. Okay, so there's our derivative, and our differential then, I'm just going to clean it up and bring my dx over, equals to 2, let's go, cosine of x minus x sine of x. And all this is going to be times dx then, because we're bringing it over. And then the last one for d, 1 all over x, so our derivative is going to be x to the negative power, right? So we'll have a negative x to the negative 2 would be our derivative. So dy dx equals a negative x equals negative x to negative 2. So our differential is going to be dy equal to 1 all over a negative 1 all over x squared times dx. And that's all it is. All right, so pretty simple stuff. A couple more here. Here's one we're just doing the chain rule. So when we do the chain rule, we'll do our derivative and take it times dx. So our derivative, dy dx, equals, okay, well, we had to take the derivative of the outside, which is going to be cosine 3x, leave the inside alone, and then we take it times the derivative of the inside, which is just 3, and then times, oh, that's, sorry, as you do my derivative, I'll rewrite it and write our differential. So dy equal to 3 cosine 3x times dx. And that's all it is. And another example of the chain rule, notice we have a function inside of a function. So we have an inside and outside. Let's do the derivative of the outside first. So dy dx is going to equal 1/2 x squared plus 1 to the negative 1/2 power. And then we have to take it times the derivative of the inside, which is just going to be 2x. Okay, and now let's clean it up and write our differential. So we'll say dy equals, we'll just have a 2x on top, and we'll have 2 times the square root of x squared plus 1. And then this is all times dx. And that's all it is. Okay? How we use some differentials, we can use these to approximate function values, just what we were doing in the last couple of videos. But here's another example. All right, I'm going to use differentials to approximate 16.5. Obviously, we could use a calculator, but it's kind of fun. We can use a little calculus and figure out for ourselves. What if I just say, okay, let's replace 16.5 with just x. So let's use differentials. Let's use this up here to approximate what the square root of 16.5 is. So when I use, so what we're going to do, so I have f of x plus f prime of x dx. So I need to find my derivative then. My derivative is going to be 1/2 x to negative 1/2. So if I were to write right here, my equation to approximate my differential for this case is going to be the square root of x plus 1 all over 2 times the square root of x times dx. Okay, so that's just using this right here. Take the derivative, and so we'll be able to use this to approximate. Now let's just pick an easy value for x, and then you use dx as our change of x like we did in the last couple sections. So the closest perfect square I know is 16. So let's plug 16 in for x. So the square root of 16 plus 1 all over 2 times the square root of 16. And now to get what my change of x then, my difference between 16 and 16.5 is, take it times 0.5. So I'm going to have 4 plus 1 all over 2 times 4, which is 8, times 1 half. 0.5, same thing as 1 half. So I have 4 plus 1/16. When we do that, I think 1 divided by 16, to change that into a decimal is, so this, if I were to type that in a calculator and divide 1 divided by 16, 0.625. If I were to go ahead and take the square root of 16.5, I get, here's what I get when I type it in my calculator, 4.062019202. Pretty close, 0.625, 0.621. Not too bad, huh? Okay, so we're using differentials to approximate that function there, the value of the function there. So here we go. Let's try this one. Now we have the cubed root of 28. So let's write our function. So our function is going to be f of x is going to be the cubed root of x. Let's find our derivative. F prime of x is going to be, let's see, 1/3 x and negative 2/3. All right, and let's plug that back into, so what we're going to take is we're going to have the cubed root of x plus 1/3, whoops, wow. You have 1 all over 3 times the cubed root of x squared. That's what it means, the 2/3 power, the cubed root of x squared times dx. All right, well, the closest perfect, you're not perfect cube, closest cubed I know is 27. So let's do the cubed root of 27 plus 1 all over 3 times 27 squared, the cubed root of 27 squared, times, now my difference is between 27 and 28 is just 1. So we'll take the cubed root of 27 is 3 plus 1 all over 3 times 27, the cubed root of 27 squared, which is 729. The cubed root of 729 is, I believe, 9. Okay, so I'll have 1 all over, or sorry, I'll have 3 plus 1 all over, this is 9. 3 times 9 is 27 times 1. So when I figure this out, 1 divided by 27 is, so this equals, when you type in your calculator, 3.037. 037, and it keeps repeating like that. If I were to go ahead and take the cubed root of 28, I get, this is what my calculator says now in green here, 3.0365889. That's pretty darn close to that, 0.3, close all the way up until here. Okay, so just showing you the power differentials here a little bit. Last one, use differentials to approximate 2.99 to the 3rd power. Well, let's write our function. We get a little better x there. Equal to x cubed. Let's find our derivative. Equals 3x squared. All right. And so to approximate this function, we're going to say dy equals our function plus our differential, 3x squared dx. Okay. Pick an easy number to use. Let's pick 3. So dy would equal 3 cubed plus 3 times 3 squared times dx. Now, my difference then is 2.99 minus 3. So my difference between 2.99 and 3 is a negative 0.01. Okay, so 3 cubed is 27 plus 3 squared is 9 times 3 is 27 times a negative 0.01. Okay, so 27 times 0.01, you just move the decimal place 2 spots over. So 1, 2. So I'm going to have 27 plus a negative 0.27. So I'm going to get 27. So when we subtract those two, when we subtract those two, we'll get 26.73. All right, when I type that in my calculator, which I just dropped, and it's graphing some crazy function now. What I just dropped, when I type in 2.99 and I cube it, I get 26.730899. Like so, that's pretty darn close to that. Okay, so hopefully this stuff helps, and we'll see you in class tomorrow.